In the last part 5 here of the second semester final exam review, the only thing we have not yet talked about is our calculus chapter. And our calculus chapter included limits, derivatives, and integrals. On the final exam, we're going to cover the most basic information, but one of the things that I want you to be able to do is I want you to be able to use your graphing calculator to find a limit at a certain value. So if you think about a problem like this, the limit as x approaches 0 of the sine of x over x. First of all, you know that you can't plug 0 into this expression because you're going to get 0 in the denominator. Well, if I'm going to get 0 in the denominator and I have no process of trying to factor and cancel stuff, what am I going to do? Well, we're going to plug this into our graphing calculator. A couple things I want to remind you about plugging into the calculator. The first is that you're going to need to change your table setup. So table setup was under second window. You want to use your table start to always be what your limit is going to. So if your limit is going to 0, you're going to change that to a 0. And then your delta table, that's your intervals that each x value is in. Normally, your calculator, it would say 1. That means that when you go to the table function, you see 0, 1, 2, 3, 4. If you changed that to a 2, it would go 0, 2, 4, 6, 8, 10. You change it to 0.1, it would go 0, 0.1, 0.2, 0.3. We found out that for our purposes, it's best to change this to be 0.001. Once you've done that, then you can go and put your equation into y equals. Now, with a trig function, if you were to run across a trig function, just a reminder that you probably should be in radian mode. And the only time it really matters is when you're using a trig function in the graphing part of your calculator. Then you go to the table when you're done. And then I would get 0 into the middle of the screen. And then you want to look at what the y values are doing on both sides of the error message you're going to get. Well, you're going to notice that all the y values are 1. So the limit as x approaches 0 of sine of x over x must be 1. Now, you actually can use this graphing process on the calculator for any problem, whether you can find the limit by just plugging in the limit or not. So let's look at this problem. The limit as x approaches negative 4 of x squared minus 16 over x plus 4. You know if you plug negative 4 in here, it's going to give you an error message in the denominator. So we need to find another way of doing this. Well, you can use the process on your calculator by plugging in the table start at negative 4. Your delta table would be 0.001. And if you plug this into y1 equals, make sure you put this into parentheses. But there's another way of doing this problem. You could factor the numerator, and then you'll notice that these go away. So you're actually left with the limit as x approaches negative 4 of x minus 4. Well, now you can plug negative 4 in without getting an error message, and you're going to find out the answer is negative 8. You can do this on the calculator as well, whichever method makes you happier. Again, here's another problem that I actually showed you how to do algebraically, but you can also just plug it into the calculator, making sure that that is in parentheses. And that doesn't need to be in parentheses, but when in doubt, put everything in parentheses. If you have the TI 84 or 83 that does not have the new operating system, when you plug this in, you're going to have to close the radical in the numerator, and then you'll have to close the numerator before you type in the rest, if you want to use the calculator. However, I'm going to talk about how this worked algebraically. We did something called rationalizing the numerator, which was a little different from what you had learned in algebra and geometry, which was called rationalizing the denominator. But it's the same process. It's just instead of rationalizing the denominator, we're rationalizing the numerator. The reason we're doing that is because what's going to happen in the numerator is you have a minus ba plus b. And when you multiply those together, you get a squared minus b squared. I can't even write this little b up here for some reason. There we go. So when you multiply the a times a, what happens is you're squaring a square root, and they go away. Minus 3 times 3 is going to be 9. And then I'm not even going to multiply out the denominator here. I'm going to just leave it like this. Because what's going to happen is in the numerator, 9 minus 9 cancels, and then you're left with this x and this x, which go away. So you've got 1 divided by the square root of x plus 9 plus 3. Now I can find the limit as x approaches 0, because when I plug 0 in for x, the denominator is going to be square root of 9, which is 3, plus 3, which is going to give you 6. If you were to do this in your calculator, you wouldn't get 1/6 as your answer. You'd get 0.166666 forever. Just a reminder, on a multiple choice test, if you do this on your calculator and the answer is a fraction, but you're getting a decimal, just turn the multiple choice answers into decimals. You will figure out very quickly which one's the right one. Some limits you didn't even have to put in your calculator. As long as the value your limit is approaching does not make the denominator of a fraction 0, then the easiest way to do this problem is really to just plug in the limit for x, because the limit's going to be the y value at that value of x. And it turns out that I can plug 2 in here because the denominator is going to be 4. And the numerator is going to be 4 minus 2, which is 2, plus 6 is 8. So it turns out that the limit is 2. So before you go through the process of putting it in the calculator, ask yourself if you can actually just plug in the value for x and get an output of y, because that y value is going to be the limit. After limits, we talked about something called the derivative. And the derivative was the slope of a tangent line at some value of x. In other words, because you're finding a slope, you're finding a rate of change. So in calculus, you'll do a lot of problems, sort of like some of the word problems that we did, finding rates of change, and really all they require you to do is find a derivative. So, you know the short way of finding derivatives now. And that's what I hope that you're going to use on the test. So let's say I tell you that g of x is equal to 2x squared plus x cubed. And I want you to find the derivative at x equals 1. Well, the way the derivative works is you multiply by the exponent, and then you take 1 away from the exponent. Any constants already in front of the variable, you multiply. So you're going to do the coefficient of 2 times the exponent of 2, and you take 1 away from the exponent. You're also going to take the derivative of x cubed. You take the derivative of each term. Well, it becomes 3x squared. So the derivative is 4x plus 3x squared. Now to find the derivative at x equals 1, you're going to plug 1 in for x. And remember, that just tells you the slope of the tangent line. However, what if I said, write the equation of a line at a certain point? Well, I'm going to have to give you the entire ordered pair. So in this example, let's find the equation of the tangent line of the curve at the point 1, 1. The equation of the tangent line is the same thing as finding the derivative. So first we're going to find the derivative of 2x minus x cubed, which is going to be 2 minus 3x squared. Now that I know the derivative, now I can find the tangent line. Well, first of all, I have to find the slope. So I'm going to have to plug 1 in for x. And I'm going to find out the slope is -1. Once you find the slope, then the easiest way to write the equation is to use point slope form. And this is what the calc students use, and this is what it will be written as on the final exam. So the point was 1, 1. So I'm going to do y minus 1 is equal to -1, x minus 1. Sorry. And that's probably the easiest way to just leave the answer. If you feel like you want to distribute out, that's fine. However, on the final exam, the problem that is like this, the answer will be left in point slope form. So just a reminder, the way that a derivative works, if you have f of x is equal to some constant times x to the nth power, you find the derivative by putting the exponent in front of x and then subtracting 1 from the exponent. What happens though is, what if you're taking the derivative of a constant? Well, the derivative of a constant is just 0. And then what tricked a lot of students is if I said, what is the derivative of this, where the exponent is 1? Well, the derivative of this, because you're taking away x's, well, there's only one x there. What happens when you take away an x? You're just left with this. Those are your basic derivative rules. What if instead I gave you this problem? I said, find the derivative of f of x is equal to 3x minus 1 squared. In calculus, you will learn another way of dealing with this particular problem. However, what we're going to do is we're going to start by distributing it out. Remember, squaring means multiplying by itself. So when I do that, I get 9x squared minus 6x plus 1. Now I'm going to find the derivative. And the derivative is going to be 18x minus 6. So for a problem like this, the best way to deal with it is to multiply it out first and then find the derivative. Another type of limit we talked about were your limits at infinity. Limits at infinity are just horizontal asymptotes. Now, one way of doing limits at infinity is to just graph something on your calculator and look at what happens as you continue to go to the right on the graph. That would be x approaching infinity. And then if I said what happens to a graph as you approach negative infinity, you would look at the curvature as it goes to the left. Well, really, it was just a horizontal asymptote. So if we gave you a problem like, what's the limit as x approaches infinity of 6 over x? Well, the way the horizontal asymptote worked was you looked for the biggest exponent of x in the numerator and denominator. Whichever one had the bigger exponent of x, you got different answers. Well, this one, because the bigger exponent of x is in the denominator, because there's no x in the numerator, the limit as x approaches infinity is 0. However, if I gave you this problem, I want you to notice that the biggest exponent of x in the numerator and denominator is the same. So the limit would be the ratio of the coefficients. What happens, though, if I give you this problem? The limit as x approaches infinity of 3x squared minus 5 over x plus 2. I want you to notice that the biggest exponent of x is in the numerator. When that happens, there is no limit. Unless you are looking at a one-sided limit rather than a two-sided limit. The last thing we talked about was the integral, which was also called an antiderivative. It was for finding the area under a curve. And there are two types of integrals. There's the definite integral and the indefinite integral. The indefinite integral is the one where I give you a problem like this and I say f of x, or I'll do it this way instead. I'll say find the integral of 3x squared dx. When there are no values next to the little extended s sign, this is called an indefinite integral. And the way the antiderivative worked was you would do 1 divided by 1 plus the exponent, and then you would add 1 to the exponent, and you put a plus c at the end. The reason we put the plus c at the end is because with a derivative, constants went away. With integrals, we're going the other direction. So you got to add that plus c back, and in calculus, you'll learn how to find c. Well, this becomes x cubed plus c. So the antiderivative rules, or the integral rules, if f of x is equal to k times x to the nth power, you would find the antiderivative or integral by doing k times 1 over n plus 1, x to the n plus 1, plus c. And that was the basic integral rule you need to know. The other thing we did was we found a definite integral. A definite integral is one where you would first find the integral. When you're finding the integral, you find the integral of x, which is going to be 1/2 x squared, and then x squared becomes 1/3 x cubed. But we don't use c in these problems because we don't know how to find it yet. The fundamental theorem of calculus says plug in the top number first, and you're going to get an answer, and then you're going to subtract from that the answer you get when you plug in the bottom number. Well, I picked a relatively simple one here because this is just going to be 0. This side is going to end up being 1/2 plus 1/3, which is 5 over 6. So the answer is 5 over 6. So the area under the curve of x plus x squared from 0 to 1 is 5 over 6. And that is the semester 2 review.